Okay, so I'm going to look at this, and I'm first going to observe that for big values of k, I have roughly like k on the top, and in the bottom for big values of k, well, I have basically the square root of k to the power of 5, in other words, k to the power of 5 halves. So I'm thinking that I want to somehow, I don't know how yet, I want to compare with k over the square root of k to the power of 5 plus 1. This is k over k to the 5 halves. So this is going to be 1 over k to the 3 halves. And since the series with terms 1 over k to the 3 half converges, I think this is also going to converge. Okay, so now there's a couple of things that I can do. So if I think, so I need to be thinking either direct or limit comparison test. And to do that, I need to make sure the terms are positive. Well, notice that k plus k sine k is equal to k times 1 plus sine k. And this is always greater than, this is always greater than 0 because sine k is always less. If k is an integer, sine k is always less than 1. Or sorry, if k is an integer, sine of k is always greater than minus 1. So 1 plus sine k is always greater than 0. On the other hand, I know k 1 plus sine k, again, well, for any value, whatever, even if we allow non-integer values of k, k times 1 plus sine k is always less than or equal to 2k. And if we just look at integer values of k, it's always strictly less than 2k. Okay, so k plus sine k over the square root of k to the power of 5 plus 1 is less than or equal to 2k. We know this is true. It's less than, it's positive. It's less than or equal to 2k over k to the power of 5 because the square root of k to the power of 5 plus 1 is greater than the square root of k to the power of 5, and this is equal to 2 over k to the power of 3 halves. Since the series 2 over k to the power of 3 half converges by the p-test, this series converges, the series under question, by the direct comparison test. But please keep in mind, if we want to use the direct comparison test, we have to make sure that the terms of this series are all non-negative, and that's what this does here. And then this right here is where we show that, the second thing, this is where we show that the numerator is less than or equal to 2k. But to do the direct comparison test, we first have to make sure that the terms of this series are non-negative.